I'm going to teach you something that is very, very common in calculus. It really has nothing to do with calculus. It's an algebra skill. But in calculus, you're going to need it frequently, almost every day. You having fun there, Hannah? Okay, so you're sitting in the front. Let's say I had some equation that said, okay, hold on, I gotta do this in my head. So after all we did last year and this year, you should be able to do this. How are we going to solve this equation? What's that? We're going to do page, so we're starting on 121. So how do I solve this? No, it's a quadratic, so I need to equal it to 0. If it was just 6x, then you would move the 25. Now, because it's an x squared and an x, we can't get the x by itself, so we have to add 15 so that it equals 0. Oh, shoot. You're going to be mad at me if I change all the signs. So negative 25 and a positive 15, so I'm going to add 15. Nope, subtract 15. And I get x squared minus 6x minus 40 equals 0. Apparently I can't do things in my head. Now what? So hopefully it factors. X minus x plus. Are there two numbers that multiply to be 40 and add to be 6? Positive 4 and negative 10, so my x values are 10 and negative 4. Now, in a lot of things we've done lately, you have to go back and check to make sure that the numbers are okay. The problems we ran into were negative square roots, denominators equaling 0, and logarithms of negative numbers. And in this case, none of them apply, but you might have to think about that in the future. When you get a quadratic equation and you solve it, you have to look back at the original problem and determine, do I need to plug something in or not, to check. And in this case, no. Okay, so, actually, let's just do that. What if I had x plus 3 squared minus 6 times x plus 3 minus 40 equals 0? How would I solve this? Okay. So the way that you've done this in the past is to distribute all this out. So x squared plus 6x plus 9 minus 6x minus 18 minus 40. If you don't write this down, I don't care. You can just watch for a second. So x squared, oh, that's kind of nice. So minus 9 minus 40 equals 0. So that's negative 49, I'm going to add it. So x squared equals 49, square root, x equals plus or minus 7. And that one actually worked out to be a lot easier than I thought it was going to. Usually what happens is you end up with a quadratic that you factor in the end. Okay? But, did anybody notice anything about this before I started solving it? Not in this case you can cancel, but that doesn't always happen. Does anybody see a resemblance between this problem and the last one? So the last problem was x squared minus 6x minus 40 equals 0. Right? What were my solutions? So x equals 10 and negative 4. Well, instead of x equals 10 and negative 4, what is it? It's actually x plus 3 equals 10 and x plus 3 equals negative 4. So I subtract 3 in both cases, and I get x equals 7 over here and negative 7 over there. So really what we have is a quadratic equation, but my variable is no longer a monomial, one term. My variable is now a binomial. So before, this was just an x, but now it's an x plus 3. And things can get quite complicated in dealing with this, but you can see, if I know how to solve this thing, then it's just one short step to solving the whole thing, as opposed to doing all that multiplication and combining and then refactoring. All right? And this is something you do in calculus all the time. And we call it, and I don't know why, we call it U substitution. And U substitution can be your best friend. The trouble is there's not necessarily one way to do it. I might pick one U substitution and you might pick another and we both get the same answer. Okay? So, what I'm going to do is define the variable U. I don't know why we use that variable, we just do. So I'm going to call U x plus 3. Because I see two x plus 3's in the equation, so I'm going to solve the quadratic and then deal with the x plus 3 at the end. So to rewrite this quadratic, I have u squared minus 6u minus 40 equals 0. So technically I haven't changed anything, I've just hidden part of the problem, and I'll deal with it later. So I factor this, u minus 10 and u plus 4. So I get u equals 10 and u equals negative 4. Now that I've solved for u, I bring in the x plus 3. X plus 3 equals 10. X plus 3 equals negative 4. And then I solve for x, and I get that plus or minus 7, which will save you a ton of work. Okay? Now, you know how to solve this without u substitution. And u substitution makes it easier, but when you get to calculus, a lot of things cannot be done without u substitution. And you actually have to get really clever on how you do it. So if you look on page 121, there's a u substitution problem. So I'm looking at example 5. So we're going to define u equals 2x plus 5. And then we have the quadratic, u squared minus 3u minus 40 equals 0. Yes, you define u every time you have one of these. And you could do it the long way, but does anybody really want to multiply that out? No, I don't want to. So if I solve this, u minus and u plus, are there numbers that multiply to be negative 40 and add to be negative 3? 5 and 8, so the 8 is negative, and the 5 is positive. So u is really 2x plus 5, which equals positive 8, and 2x plus 5 equals negative 5. Solve for x. Eight minus 5 is 3, so x equals 3 halves. So 2x equals negative 10, divide by 2, x equals negative 5. The nice thing about this answer, if we would have multiplied them out, we would have got a quadratic that said 4x squared plus something, something, something. And because of that leading coefficient, I would have had to do the hard factoring, where you multiply the first two together and then factor and group and that big mess. But because I used U substitution, I was able to use the simple factoring method, which is nice. Okay, do I need to worry about any undefined areas? We don't have square roots with negatives, we don't have numbers in the denominator, and we don't have negative logarithms. Okay? So look at example 6. What should I choose for U? So U equals 2x minus 1. So my equation becomes 1 over U squared plus 5 over U equals negative 6. What should I do? Get a common denominator. So what is the first denominator missing? Nothing. So I can have 1 plus. What is my second denominator missing? A U. So I put a U in the top. 5U. What is the last denominator missing? U squared. So equals negative 6U. Now think about if we did it the other way. Oh, U squared. Thank you. I would actually have to times this by 2x minus 1, and I would have to times this one by 2x minus 1 times 2x minus 1, which is a terrible mess. But in this case, now they're all divided by U squared. Because they're all divided by U squared, I can just drop the denominator. So once you have a common denominator, then you can just get rid of the denominator. So I'm going to add the 6U over. 6U squared plus 5U plus 1 equals 0. In this case, we can't avoid the terrible factoring. What should I do? Multiply these together. 6U squared. I know the signs are both positive. Are there factors of 6 that add to be 5? 2U and 3U. So I'm going to bring down the first and bring down the last. 6U squared plus 2U plus 3U plus 1. So now I group. What does the first group share? 2U times 3U plus 1. And what does the second set share? Nothing, so we use a 1. So plus 1 times 3U plus 1. So I'm left with 2U plus 1 equals 0, and 3U plus 1 equals 0. What does U equal? What was it? I don't remember. 2x minus 1. So up here, 2 times 2x minus 1 equals negative 1. So I'm going to divide by, well, let's times that in. It'll be easier. So 4x minus 2 equals negative 1. If I add 2, I get I moved this over. Sorry, I skipped a step. So negative 1 plus 2 is 1, and 1 divided by 4, x equals 1/4. I'll do this one slower. So I'm going to put inside here 2x minus 1. Okay, so 3 times 2x minus 1 plus 1 equals 0. Does that make sense? So I distribute in 6x minus 3 plus 1 equals 0. 6x minus 2 equals 0. Subtract the 2, divide the 6, and x equals 1/3. Now, do I have to worry about zeros in the denominator or negative square roots or logarithms? If I go back to the original problem, I do have variables in the denominator. So what were my answers? 1/4 and 1/3? Is that right? So if I plug 1/4 in here, am I okay? 2 times 1/4 is 2 minus 1 is 1. I'm fine. The only thing I'm not allowed to do is divide by 0. If I plug 1/3 in there, 2 times 1/3 is 2/3 minus 1 is not 0, so we're okay. Both of these solutions work. Trying to get in the hang of this? Yeah, they're supposed to. Okay. Sounds good to me. Okay. Why did they do they didn't do use substitution here. Okay, that makes sense. All right, so 4x to the third times 8x squared. I don't really know why they put this in here, but maybe it'll apply. So I need to set it equal to 0. So 4x to the third minus 8x squared equals 0. Can I pull anything out? I can pull out an x squared and of 2, but a 4 would be better. So I'm going to pull out 4x squared. What's left? X minus 2 equals 0. And if you ever have two multiplications that equal 0, like a times b equals 0, what do you know about a and b? One of them has to be 0 or both. So if a is 0, then it's true. If b is 0, then it's true. And if they're both 0, it's still true. So all we do is set each of these equal to 0. Well, 4 times what number squared is 0? 0. So one of the roots is 0, and the other root is going to be positive 2. Good. Okay, I wish I had answer sheets to this, but alas, they didn't come with the book. So your assignment today is page 122. If you don't have your book on you, I'll leave this up. Actually, why don't I push this button? Oh, but that won't show up on the... Hang on a second. I got to turn the video off. Okay.